Aloha, Richard Halverson here. This is ICS211, and today I'm going to do the lab 6, the Dijkstra shortest path lab. So let me share my screen. So I'm doing this one here, and we're supposed to go to this section in our textbook and see this Dijkstra's demo program and execute it, and you'll see the output looks like this. Basically, it's a directed graph that's got nodes A, B, C, D, E, F, G, and it computes the shortest path from A to each of the other nodes and displays out the result here. Let's take a look at it. Let's go to the book here, here, here. Here, 211, and it's in chapter 21, and it's this Dijkstra shortest path. So you should read this, see how it works. It basically computes, cycles through everything, computes the paths back, and does some clever algorithmic things, and has this table, and it's able to generate the shortest paths. What happened? Oh, it's down here. All right, so it's this is the program, and so I'm gonna this is the demo, and then it's got 3 classes that it uses, and if you just simply run the program, you see this is the output here, and the graph is implemented right here. This is where we create these vertices, and here's where we say what the weights are, the distances between the vertices, representing this particular graph here, and then this computes it. Dijkstra's, this one, the graph, I think this is, well, this is the graph, and all the outputs and all the edges and everything, but the actual Dijkstra's algorithm is in here, right about here. Get shortest path. All right. Anyway, so let's start by just copying over all of the files. I'm going to do this. I'm going to use Visual Studio today. And so I'm going to open up a new Visual Studio. I'm going to, if your screen doesn't look like this, you can always open a new window and it'll look like this, should look like this. I've installed the Java extensions, the Java extensions package. It's this one, extension pack for Java. I've installed that. So I'm going to just start out by creating a Java project, and I'm going to select this project type, and then it asks me to open up the location, and I'm going to just go to the desktop, and I'm going to create a location, a new folder called lab 6 shortest path. How's that? I don't know. That's going to be my project location in there. And then I'm going to have a project name, and I'll call it shortest path. Enter. All right. So let's go into here, source app Java. I think this is the class that's got the static void main in it, so we can use that. I think we can rename it. I think I'm going to rename this Dijkstra's, Dijkstra, Dijkstra's demo. And yes, go ahead and do all these things. Change all the names everywhere, and now it looks like this. And now I might as well, while I'm at it, create these other 3 files, a graph. So I can just go file, new file, new Java class, graph, enter, and then new file, new Java class, edge, enter, and then new file, new Java class, vertex, enter. Okay, now I got these 4 files. Now I gotta just populate them. Let's start with vertex, why not? And let me that over there. So let me go to vertex, and it looks like I just have to copy this. Copy, paste. Looks fine. Let's go to edge, and I'm going to copy and up there, paste. Okay. And let me go to graph. Let me move this over a little bit. Can I? Graph, and let me go to graph. And here I better put this up there. Copy. Put this up above it. Paste. Turned out bad. Enter, up, paste. Okay. And I guess it's okay, class. Okay, it's okay. I'm going to copy all this onto here. Copy and paste it right in here. And the last one is going to be Dijkstra's demo. Over here, Dijkstra's demo. And I better copy all this stuff up here at the top. Click enter right here. Excuse me. Paste. There's those things. And then underneath here, oh, I got to copy this class. This class here. Copy. That goes right after here. And then I can copy Dijkstra's demo, which is right here. So, oh, there's a public static void. Oh, I got to copy this because above the public static void. Here we go. Oh, so is this string shortest path. Here's the public static void. So I have to copy all of this here. Copy that. And that goes right inside, right after the declaration. Let me do a paste. And I just pasted this Dijkstra's shortest path method here, which returns a hash map, and the hash map is what's used to figure out, uses the hash map then to figure out the shortest path, runs this thing. And the public static void main program is, let me copy this out. There. No. Copy. And that gets pasted. I can get rid of this hello world. And I'm just going to paste. And let's see. Let's move this over a little bit and open it up, and we can try to run it. I'm just going to do run, see what happens. Run, start debugging. Oh, am I lucky? There it is. Just runs away. So there it is. Great. Okay, so now what I would do is I would, because I've got to take a screenshot, right? Where's the? I'm supposed to screenshot of Dijkstra's demo Java. Okay, so take a screenshot. So for this one, doesn't matter too much what's here. It'd be nice to see the files. Let's make it bigger. It's nice to see the files here. It's nice to see some code up here. And this is the terminal window right here. And this is you remember I said it shows something that's unique, that would be unique to you, and probably whatever this is up here, this blue and this line right here, that would be unique to you. And I can see what the name of the program is that you ran, from where it came from. This is the output. So just take the screenshot. I'm gonna take a screenshot here. New. And I'm gonna go Dijkstra's demo. That's good enough. And I'm gonna save it. How about if I save it inside here? It doesn't matter. Save it, call it, oops, how did I do that? Dijkstra's DIJKSTRAS DEMO screenshot, REENSHOT. Enter. Okay. So that's that. And now let's go to part 2. Part 2 is to create a copy of Dijkstra's demo Java in the same package named Dijkstra's demo 2 Java. And you better remove this class, because otherwise it'll conflict, because you're going to have both of these Java programs in the same projects. So here's what I meant. Create a new file, Java class called Dijkstra's demo 2. Okay. And I would like you to copy Dijkstra's demo. And in fact, I'm just gonna, what the heck, I'm just gonna copy this whole thing. Copy, and I'm gonna go over to Dijkstra's demo 2, and I'm just gonna go paste, but I better change this to 2. Okay, is this all okay now? Okay, next I want to get rid of this class up here, because this class is already in the other one, and I don't want it to conflict. So there. And now I think it's in this other thing. This is the only thing that used comparable, and that's what that's for. So over here, that's why this has got a squiggly line. I don't need it there. I'm just going to comment it out and I'm gonna try to run this demo 2 just to make sure this part works, because then I'm going to start modifying these. And so I'm going to run this, run Java, and it compiles okay. If I would have left that duplicate class in there, it wouldn't have compiled okay. But this runs. So I can see Dijkstra's demo 2 is the one that ran, and so it works. I copied it over successfully. Now I'm going to modify Dijkstra's demo 2 to do what I'm asking for here. And the idea is the graph is going to stay the same, but when we do this shortest path, algorithm, when we execute the shortest path algorithm, which is right not this one, it's not that one, it's down here. This is okay. This is where we build the shortest. This is here is where we build the graph. And this is where we create the Dijkstra's shortest path hash map that's got all the information in there. So it's got all the information in there for to run this get shortest path. And let's see, where is that? Here. So this thing creates all the information for the shortest paths between vertex A and all the rest of the nodes in G. This is G. This is the buildup of G. So this builds this hash map of all the information it needs to be able to inside this for this graph to compute distances, shortest path distances from vertex A. And then we go through this loop here, which it loops through all the vertices, and it computes the shortest path between vertex A and whatever vertex we want to compute the shortest path for. And what this does is this goes through all the vertices A through G, and right here, that's this, and it computes the shortest path from A to whichever one it's on, and this is these things display out. See, A to A to B, A to C, and so for our program, we want to make it so this is this is input. See, right now this is hardwired, so it always computes the shortest path from A, and we want to first ask the start vertex, and in this case it's A, and then we need to see. So this is input, and then this hash map is created for A, and then it's able to answer the question of from A to whatever. And in this case, it would be outputting just this one. In this case, we aren't using A, we're using E. So this is going to be vertex E. And so this thing is going to have all the data for the shortest path from vertex E to all the other ones. And so then this shortest path can run where instead of it being A, it's E, and then it can answer this question from E back to A, for example. And then this third example, it's G instead of vertex A or vertex E, it's vertex G, and so on. Okay, so so for this part, for the first part, we need to be able to ask the user what this is going to be. And then for this part, we need to ask the user which one of these outputs do we want to output. See, we don't have to output all of them anymore. We only have to output the one that the user wants. So this is the start vertex, and then you ask the user what the ending vertex is, and for this one, this means you only have to print out the one from A to G, and that would be this last one, A to G. See, so you can go through this loop, but you only print out the one that you asked the user for. So that's going to be our strategy. Well, the hard part, and so I'm going to help you through the hard part, and then after that you can figure out the not so hard part. I'm going to tell you how to make this variable. Right now, this is a hard-coded vertex A. How do you make it variable? Okay, well, you got to do some fancy stuff up here. Instead of you want these things to be like in an array. Like vertex is the name of the array, and then the index can be like whether it's A or B or C or D. Well, that sounds just like a hash map. So let's create a hash. Let's make our vertexes be inside of a hash map. All right. So let me add some notes around here someplace. I don't want to confuse everybody. So let's see, what am I going to call my hash map? I use vertex down here. So I'm going to just call it, I guess I'll call it vertex 2 or something. So I'm going to create a hash map, and the key is going to be the letter A, B, C, D, E. So it's going to be a string, and the value is going to be a vertex. So I got to put vertex. This is the vertex class. Okay, so this is a hash map of that. The keys are strings and the values are vertexes. And I'm going to call this vertex, I'll call it vertex 2, just because I can't think of anything else. Vertex 2, and that's going to equal a new hash map of string. Interesting. String vertex. Okay. So that's going to be my hash map. And then I'm going to, instead for vertex 2, I'm just going to go, I'm just going to start it out here, and I'm going to probably delete. It's vertex 2 dot put. We're doing hash maps now, and it's going to be A, and that's going to be the key, and the value is going to be a vertex, and it's going to be a vertex like this is a vertex. That's a vertex. This assignment statement assigns this vertex object to this vertex variable. And so I'm going to just take this. This is a vertex. Doesn't let me copy, and I'm going to paste that thing right here. So this is going to add vertex, a vertex named A is going to be the value that's put for this element that we're putting into the hash map, into the vertex 2 hash map, with a key value of with a key of capital A. All right. And I got to do the same thing all the way up to G. Now I could do it whatever. Let me just be lazy here. Ooh, what did I just do? Okay, 1. It's A. Ooh, what am I doing? Okay, that's A. Hold on here. All right, let's see. Got to copy this. So I was going to copy it and then go B, C, D, E, F, G. Okay. And then I was going to go capital back B, down back C, down back D, down back E, down back F, down back G, and back B. Okay, that takes care of those 3. And I'm going to comment this out. I can get rid of these comments. And oh, I don't need this anymore because because this is all this is used for. It's an array of these vertices, because down here it's going to have, with this for loop, it's going to loop through the array of vertices. We actually don't even need the for loop because we're only looking for one of these lines, but I'm going to leave that to you. And so this traverses through the vertices using this enhanced for loop. We can use an enhanced for loop, but we can traverse through the keys of the hash map. So we have this hash map up here, and so we don't need that. So I'm going to comment it. I'm going to make the comment go all the way here, because it knows better. Okay, so here I'm just commenting this stuff out so I don't get that confused. And then this adds, here we're adding the undirected edges to G. And so we need to replace vertex A with how we reference vertex A. And so I think I can just do this. I'm going to say vertex A replace vertex A with vertex 2 get A. Okay. And I think I can do all. So how do I do all? Replace all. Boom. Okay. And now I want to do B with B. And then I want to do C with C. Then I want to do D with, I hope this is working. I'm not doing here. I'm just kind of on autopilot here. F, D, O, E, E. What's going on? What are those words key there for? F, and I guess I gotta get F. I don't know what all those keys are. I'm gonna have to get rid of all those keys. I don't know what that means. Somehow that probably got popped in there when I wasn't looking. This is F, and this is gonna be G. Okay, now I don't know what all these keys are for, but I think I'm just gonna leave, because maybe it thinks it knows better about something. So I'll leave that there to see if that's okay. All right. And so I've done all that. So I've changed I've loaded up G, and I've loaded up vertex 2, and now I'm gonna loop for here I want to let's see. I'm looping through all of the vertices. I guess I'm gonna loop. I guess I want to loop through like A through F or something. For string. end vertex. Oh, wait, no, it is vertex, isn't it? Let me go back to it. Yeah, let me try doing it this way. For each vertex in let's see, I need to check something. All right, I did a search on how to iterate through a hash map by values. And so I found this, and it looks like we can just do this. So I want to iterate through this hash map by values. I'll call it vertex vertices. It's instead of vertices, it's the hash map, which I call vertex 2. And then I do values, I guess. And so let's see if this should work the same. This should work the same, I think. Let's just run this and see what happens. Run Java. Worked. Okay, so this is A, and that's why I wanted. Okay, so what's the key? I had to get the key value. I'm gonna have to say letter. Say string letter equals vertex no, it's not. Yeah, I wanted to be able to I want to get at the actual key value because I want to put the key value right here. No, I don't. No, the key value goes here. So no, I think this is fine. How do I get this is going to be the letter that's read in for the initial or what you want this to be. Okay, so let's put that in there. So we have this here, and so now let's try to vary the starting letter. So it has to be up here, and I'm going to do I need my scanner. Do I have scanner around here? Let's see. I gotta put that scanner. Gotta put a scanner in here, and then I need to down here someplace. I guess I gotta do this. So this doesn't matter where I do it. About here, and then I need to. I better print out something. System out print start vertex. And so now I do start string start vertex equals scnr dot next. Okay, so this is a start vertex, and so the start vertex should go right here. Yeah, and it should go right here. Start vertex plus. And this should also be the same thing here. Right in front of here. And get rid of. It's weird. All right. Knows better than me, I guess. Okay, oops. Screw that up. Ah, shoots. Okay. Okay, now I want to get rid of that A. All right. Oh, this should be start vertex. Start vertex. Okay, let's run this. Let's run this. I'm gonna do right click, run Java. Okay, start vertex. I'm gonna start out with just A. Where did that go? I see a mistake right here. This should be not A, but this should be start vertex. But I'm gonna write it and run it anyway. I'm just gonna put A anyway. And I get that, and let me change this to start vertex. It's weird the way that works. And I don't see any A's anymore. Okay, let's try this again. And I'm gonna try C. And so there, C to A, C to B, C to C, that looks like it could be right. All right, so now what you need to do is you need to ask for the ending vertex somewhere. And then you got to, when you go through this well, I would take out the for loop, but you can leave the for loop in there. And you just need to only print out when you need to just print out the one for the ending vertex. So it's going to be like when vertex label is equal to the end, I think. So you can look at vertex label, and if vertex label is equal to the end vertex, then that's the one you print out. Otherwise, you don't print it out. Okay, so that'll take care of that. And then a loop, you can put in a loop. You're supposed to put in a loop. Program repeats until the user enters in an invalid start index. So so you can have a loop, and as long as the start index is A, B, C, D, E, F, or G, then it works. Then it asks what the end vertex is, the end vertex. And but if you enter in something other than a valid A, B, C, D, E, F, or G, then it will then it'll quit. All right. So I think, all right. And then when you're done with this, then you have to finish, and then you want to take a screenshot again. You know, you want to take a screenshot just like before, and then to pack up this thing to submit it. I'll show you to pack it up. You can save everything. Make sure everything is saved. You can quit, exit, and then you go to where you had it. I think I had it in here. Yeah, here it is. Right here. So remember, I saved this. This is my shortest path project. See, it looks just like that. So this is what you can zip up. Right click, compress to zip file, and then this is what you can submit. This is the project to submit. This thing. Project to submit. You need a screenshot of the demo, and you also need a screenshot of. Oh, I quit it. That's why. You also need a screenshot of the Dijkstra demo 2 executing. All right. So that finishes up all the labs, and this will be posted up. And if you need any more help, just contact me. Thanks for watching.